There's one other important feature I forgot to mention about this example that has no solutions. We know they're parallel lines. We also know that the equations have exactly the same slope and different y-intercepts. I want to show you one more thing, and that is when you use substitution to solve these equations or these systems, something special happens here. So watch this. I'm using substitution and I'm setting this equation, this part, equal to this part. So 2/3 x plus 3 is equal to 2/3 x. So I learned in the last instructional video that I am trying to figure out x. So I'm going to go ahead and subtract 2/3 x from both sides because I want to get all my variables together. But something strange happens here. And the variables are canceled out on both sides. But I'm left with this plus 3 here. So what ends up happening is I end up with 3 equals 0. Well, we know that 3 will never equal 0. So in a situation where you have a system of equations with no solutions, you're going to end up with an untrue statement when you try to solve them. It might be 3 equals 0, it might be 12 equals 8. But whatever it is, it's going to be untrue. So now I want you to make sure you write down all these important pieces of information in your notes to summarize what we've learned from these videos. So I'm going to type them so you don't have to look at my very messy handwriting again. So to summarize what we learned about systems of equations that have no solutions, number 1, we learned in the graphing instructional videos that systems of equations with no solutions are parallel lines. So that's one important feature. Something else we learned about systems of equations with no solutions, their equations, they have the same slope but different y-intercepts. That's when their equations are written in slope-intercept form. And lastly, when solving these systems with no solutions or with 0 solutions, the variables will cancel out, ... and you will end with an untrue statement. So I'm just going to say example 3 equals 0, which we know is not true. All right, let's summarize what we've learned about systems of equations with one solution. So we've learned that they are lines that intersect at one point. The one point is the solution. Okay? When looking at the equations of systems that have one solution, they have different slopes and they also have different y-intercepts. Okay? And lastly, when solving these systems using graphing or substitution or elimination, which is a method you will learn about next week, you will find a value for x and a value for y and write the solution as a point or ordered pair. Example, I'm just going to make one up here, 2, 5. Okay. Lastly, let's review what we learned about systems of equations with infinitely many solutions. So when graphed, they are the same line, or one line on top the other on a graph. The second thing we learned about when looking at the equations of systems that have infinitely many solutions, the equations are exactly the same. Same slope and same y-intercept. And then finally, when solving these systems with infinitely many solutions, the variables will cancel out. And you will end with a true statement. Example, 0 equals 0. Or 4 equals 4. Oops. All right, I hope this has helped you to understand how you can identify which systems of equations have no solutions, one solution, or infinitely many solutions, specifically by looking at the equations.